In state space modeling, nth order differential equation is converted into n number of first order differential equation. Here I will derive state space model of DC motor in controllable canonical form. The equation of dynamics of DC motor is omega double dot plus 3 omega dot plus 2 omega is equal to ut, where u is the input, that is applied voltage, and omega is the output, that is angular velocity. Here order of the system dynamics is 2, so minimum number of state variable is 2. The state vector xt is a column vector. Components are x1t and x2t. Dimension is 2 cross 1. Assuming first state x1t is equal to the output of the physical system, that is omega t. Second state x2t is equal to rate of change of the output, that is omega t, and x2 dot is equal to omega double dot. Now replacing the value of omega dot and omega double dot in equation number 7, we get x2 dot plus 3x2 plus 2x1 equal to u. Now combining equation number 9b and 10, we can write two state equation. First one is x1 dot equal to x2, and from equation number 10, x2 dot equal to minus 2x1 minus 3x2 plus b. Equation 11 in vector matrix form x1 dot is equal to 0 times x1 plus 1 times x2 plus 0 times u, and x2 dot is equal to minus 2 times x1 and minus 3 times x2 plus 1 times u. This is known as state equation. Dimension of rate of change of state is 2 cross 1. Dimension of this coefficient matrix is 2 cross 2. Dimension of the state vector is 2 cross 1. Dimension of the input coefficient matrix is 2 cross 1, and dimension of input is 1 cross 1. So here it is equivalent to x dot equal to ax plus bu. Considering speed is the output, yt is 1 times x1 plus 0 times x2 plus 0 times u. So it is the output equation. So yt is equal to cx plus du. So here dimension of C is 1 cross 2, x is 2 cross 1, d is 1 cross 1 and u is 1 cross 1. So the number of input u is 1 and the number of output is also 1. So it is a seesaw system. Now using this state equation we will draw the state diagram. So the state equation are x1 dot equal to x2 and x2 dot equal to 2x1 minus 3x2 plus u, and output equation yt is equal to x1. This is from equation number 13. So first we consider output yt, which is equal to x1. Now we will get x1 from the first state equation by solving the first state equation. So there is an integrator and input to the integrator is x1 dot, which is equal to x2. Now we will get x2 from the solving the second state equation. So there is another integrator and input to the integrator is x2 dot. Now x2 dot is a combination of feedback of x1 and x2 and u. So there is a summer. The input u will be multiplied by 1 and it is the first input to the summer. Then we will take x1, the scaling factor is minus 2. We will take x2, scaling factor is minus 3. Then we will add these two, that is 2x1 minus 2x1 minus 3x2, and this is the second input to the summer. So x2 dot is equal to minus 2x1 minus 3x2 plus ut. So this is the state diagram of controllable canonical form.